Hi guys, in this next video, we're going to look at some more formulas that you have to know. And we're using these formulas when you have multiple gases that mix together to make a homogeneous mixture. So when gases mix, they mix homogeneously, which you might remember from our second unit, matter and energy. It just means that they mix together evenly. Okay, so each gas behaves like it were the only one present, meaning, in typical gas fashion, the molecules are going to spread out as far as they can and take up the entire volume of the container and the shape of the container. So the total pressure in the container is now going to be the sum of every single gas that's in there. So we're taking the pressure of every gas that's in the mixture and adding it all up to get our total pressure. So these are called partial pressure problems because you need to figure out the pressure of each individual gas first. Those are the partial pressures to get then the total pressure in the container. Now, based on what the problem gives you, unfortunately, there are three different ways. There's actually four different ways. We'll get to that at the end, though. There's three different ways for now that we can solve for a problem like this. So one way we know to calculate pressure is in the PV equals nRT formula. And if we divide both sides by volume, we get a way to solve for pressure. P equals nRT divided by V. So if it's a question that gives you moles and temperature and volume, then it would make sense to use this formula. You would solve for the pressure of each gas in the mixture. If there were three gases, you'd have a third one, and so on. And then you can add all of those up to get the total. Okay. The next one is using mole fraction, which is very similar to finding the percent. So the symbol, for some reason, the symbol for mole fraction is this symbol here, this X. So if they give you the number of moles of each gas present, you can find the total, and you would divide each number of moles for each gas by its total to get the mole fraction of each gas, and then you can use this formula to go from there. So this is if they just give you moles, then you would not be able to use this problem because you don't have any of the other information. Okay. Finally, we have this is like part of our combined gas law problem, where they give you initial conditions, initial pressures, and then you want to determine the new pressure, the pressure change when the gases are mixed together. Okay. Again, the only way you're going to know which formula to choose is by reading the question. So let's go to example number 1. What is the total pressure in a 5-liter container at 30 degrees Celsius? So look, they're giving me a volume, they're giving me a temperature that contains 0.15 moles of H2 and 0.32 moles of O2. Okay, so this is an easy one, guys. I want to use PV equals nRT, right? Or really, I would use P equals nRT over V because I want to solve for P. So I want to write down what my two gases are, right? I need to find each one separately, each partial pressure, and then I can add them both up to get my total. Okay, so for hydrogen, I have 0.15 moles. R is 0.0821. And temperature, so guys, they give me 30 degrees Celsius. I have to convert that to Kelvin, which is 303. I add 273 to that. So I'm going to plug that in for temperature. And volume is in the correct unit. So that was nice. We only had to do one conversion. So if you multiply, divide by 5. So this is the amount of pressure that's coming from the hydrogen in the mixture. I would do the same thing with oxygen. My number of moles is different. My R is still the same. My temperature is the same. and my volume is the same. And if I throw this in my calculator, I get 1.6 atm. So each gas is exerting its own pressure. And if I want to find P total, I have to add those up. So 0.75 plus 1.6 is 2.34 atms. Okay. All right, let's look at my next one. So what is the partial pressure of each gas? So they're not even asking me to find the total, which means I can skip the last step of adding everything together. If I have 1 mole of nitrogen, 2 moles of oxygen, and 0.5 moles of argon to make a total pressure of 5 atm. So that's the difference, guys. They're giving me the total pressure and asking me to find how much each gas in the mixture is responsible for. So if all they're giving me is moles, then the only formula I can use is this second formula, this mole fraction formula. Okay, so again, I want to list the gases that are in the question because I need to find each one. I have N2, O2, and argon. Okay, now if you add all of these up, 1 plus 2 plus 0.5, I have a total of 3.5 moles of gas. So that's going to be my bottom number for all of my mole fractions, 3.5, 3.5, 3.5. And my top number is how many moles are given to me in the question. So I have 1 mole of nitrogen, 2 moles of oxygen, and 0.5 moles of argon. Okay. Now, guys, this is like the percentage almost of the number of moles that each gas is making up for the total. So if I multiply this by 5, which is the total pressure, I'm going to be able to figure out what each gas is responsible for. Okay, so let's throw this in your calculator. You should get 1.4 atms is for nitrogen. 2.8, and you guys should be doing this to make sure you're getting the same numbers as me, and 0.7. So they had to give us, for this formula, they kind of have to give you the total, otherwise you wouldn't know like what each part was making up. All right. Third example for partial pressure. Let's see. So oxygen and neon are in a container separated by a closed valve. So I want to draw you guys a picture of what this looks like. The oxygen side is 3 liters and the neon side is 5 liters. So we basically have this container and one side is smaller than the other, 2 different volumes. Okay, and it says they're separated by a closed valve. So right now there's something here that's not letting the 2 sides mix. So I have, this is my 3 liter side, which contains oxygen, and it's telling me the pressure over here is 1 atm. And on this side, I have 5 liters of neon, and the pressure is 4 atms. Okay, what is the new pressure? So guys, that's your key word. They're giving you pressures and then a change is happening. We're opening the valve and now the pressure is going to be different because the 2 gases are going to mix together. So that's your clue that you want to use this formula. I had original pressures and now I want to see what my new pressure is going to be when the valve is opened. And then what is the total pressure? Okay, so let's start off with oxygen. Let's do that first. So P1 is 1 atm and volume 1 is 3. Now the other side is after the valve opens. So when the valve opens, they're asking me what the new pressure is going to be because now my volume changes. Now my volume is the size of the whole container. I have 3 liters and 5 liters of gas mixing to make up a total of 8 liters. Okay, now if you solve for X, you get 0.375 ATMs. So that's going to be my new pressure for my oxygen. I want to do the same thing for the neon. Originally, my pressure was 4 on the neon side, and it was a 5-liter container. What is my new pressure when the valve opens? Now, the neon has 8 liters of space to spread out in as well. And if you solve for X, you get 2.5 ATMs. Now, it depends what the question is asking for. This is a 2-part question, so it asked me for the partial charge of each gas, which I have my 2 answers right there. It also asks me for the total. So I'm going to say, okay, well, if my mixture is made up of both of these things, then if I add them together, I'm going to get the total, which is 2.9 ATMs. Okay? So those are your 3 big partial pressure formulas to pick from, and I hope it's pretty obvious to you which one you would choose. Now, this is also a type of partial pressure question, and it has to do with whenever you see a gas collected above water, you have to use this formula, where the pressure total is the pressure of the gas collected plus the pressure of the water vapor. So you're taking there's gas bubbles being formed up here, but aside from that, you have water in the container, and the surface of the water is always evaporating too. So you kind of have like the pressure from both of those things exerting a total pressure on the container, which is why this is considered a total pressure problem. Even though it looks as if there's only one gas present, you have water vapor present too. So, what the formula that we always want to use is pressure total equals. Now it says the pressure of the gas collected. Now, depending on the question, on the formula, on the reaction that they give you, the gases might be different. So I'm just gonna pretend, because it doesn't tell us here. I'm gonna pretend that this reaction, whatever it is making hydrogen gas. Okay, so let's say that those are hydrogen gas bubbles that are popping up above the water. Not only do we have hydrogen gas in that area, we also have water vapor, like I was just talking about. Liquids always have some sort of vapor pressure. So both of those gases are together in that space. Okay, now in this example, the pressure of the gas would be the pressure of the hydrogen, and then the pressure of the water is always going to be your second thing. Now, guys, this is something that would have to be given to you. So there's 3 things in this equation. You can only solve for one of them. So if they're asking me to solve for this, the pressure of the hydrogen gas, then they have to give me the other 2 things. So in this question, 760 torr is the total pressure. So that's what I'm going to plug in here for P total. Now, water, you can, if you look back on table H, so water's vapor pressure depends on its temperature. So that's information that we would need to be given. And even table H is given in kilopascals. And in this question, the total pressure was given to us in torrs. So we would have to give you the vapor pressure of the water at whatever temperature this experiment was happening in, if that makes sense. So I'm going to just write that here so that you don't forget. This is a given number. So I'm going to look that up and tell you that 19.83 torr is the vapor pressure of the water in this question. Okay, and then if we just solve for the hydrogen, we're just subtracting from both sides, and you should get x equals 740.17 torr. Okay, so the key word to know to choose this formula would be above water. All right, give you guys a couple practice problems, and we will see you tomorrow.